WarsawJS.
My name is Andriy Mykulyak, and on a day-to-day basis, I work as a front-end architect in Fresha. It's one of the sponsors of WarsawJS, and working with the API, with the web APIs, that is reviewing third-party APIs, designing our own APIs, refactoring them, and monitoring is part of my work. And this was the reason why I decided to give this talk, to share my experience and also to share my mistakes I did and we did, because there was not only white and bright past. Because I deeply believe that learning on others' mistakes is the best thing of learning. Just you save a lot of time. So let's start. Why the first question is why web APIs are so important? Because can we go without them? In principle, yes, but APIs have several key features that made them unique in today's economy. The first and the most important one is that you can sell your services via API. You may not create a full-fledged application, a native application, a web application. You can just create an API and sell this service. So your API can be a product. Yeah, and this is the main point of my talk. So API is a product, and you should treat it like the product. And the key features I was talking about is they are, in general, they are much faster and cheaper to develop than graphical applications, even than console applications, right? Because there are less technologies involved, less moving parts. Technologies can be safely hidden from the customers. And all this constitutes to the faster delivery. And publishing your API is a more flexible approach than giving your customers a complete application. Why? Because you never know, as a developer, you never know how your clients can or want to integrate your functionality. For example, if you're selling prints on the t-shirts, right? You can sell them via your application, yeah, as services, printing images on your t-shirts, or you can provide an API just to give the clients the ability to integrate this printing in the web shops, for example. And this would be much more, I would say, versatile and flexible approach. What are the qualities of a good API? This list is subjective. I created it after maybe several years of working with APIs, and it is divided into columns. The left column is have SDK from my language, because eventually you will have to write some code to connect with this API, with the services underneath behind this API. And if the code is already written by someone who knows this API the best, it's the perfect situation. So this, for example, for me, it's the most important point. The API should be intuitive. If developers or clients should not think about every single detail, name or endpoint or query, how it should work and why it does not work. If it's not intuitive, at least you should provide some documentation. Yeah? And the last one in this area is preferably the API you want to use should not be a vendor lock-in. So you should be really, in principle, it's much better if you could migrate from this API to the alternative one later. And these are qualities when it's from the coding point of view. But then you're done with coding, you start running your API and maintaining it. A set of different qualities become important. That is API reliability. Because if your API doesn't work, it's of no use. It doesn't bring you money, and your company doesn't profit. Similarly, if you cannot see when your API works and when it does not, it's the same situation. You should be able to see at any given moment how your API performs, where to tweak, where to pay attention. The next quality is performance. It's only the third one, because performant API which is not working, it's of no use. And the last one, because the most important quality of today's businesses are as short as possible time to market. So basically, the fastest business in the industry will get the most of the market. That's why the fastest time to market for APIs is also very important. In principle, you should strive to make this API as intuitive as it can be, but sometimes there are rough points, there are some pretty difficult questions, so you need to provide a technical support for your clients. So this becomes more and more important during the lifetime of the API. So these are pretty serious things, and how can one achieve, if not all of them, but then most of them, and not go insane, because this is difficult. For myself, I kind of make a plan how to do this, how to achieve this, and every single moment I remember that my API is a product, so I should, and I can, and I should use the same methods we use to develop products. That is, first of all, you should collect the requirements for your API. Then, before starting to write any code, just design a bit. Then probably you will want to choose the main technology stack. Yeah, that's a proper time, but you should do it wisely, because sometimes after half a year, after maybe 1 year, it can turn out that you will have to rewrite your API because you did the wrong choice or too quick choice, or you choose too quickly. When you're done with the technology stack, when you're choosing technology stack, you should really think about providing great developer experience, because it really matters. And then this is a complex question I will describe. But when you do this, you should also think about how to cope with changes, because changes are inevitable in the API world. So let's go step by step. Let's start with the requirements. Basically, you have two key questions to answer. Who will use your API? That is, who will be your clients? And most often, they will be other developers, but not always. You may write an API, for example, for quality assurance specialists, like a browser stack service, which the QAs use. Or this can be some data warehouse which business analysts will use. So you must learn who will use your API. And the second question, how these people will use your API. So these people will have some problems they will want to solve. So you should think about how your API will help these people to solve their problems. In which way? You should think about these scenarios, typical problems, and how your API, your product, will help them. Of course, these are not the only questions. There are many others. For example, what are performance expectations? Yeah. For example, extracting data from the warehouse can take 2 seconds. It's okay, but 2 seconds for getting data about logged in customer for a mobile application, it's not okay. It's too slow. Should be maybe 20 times faster. The expectation is 20 times faster. The second question is, what is expected amount of traffic? Yeah, how much resources we need, and this also can restrict our choices when it comes to technology. We should think at this point we should think about monitoring this API, and it's best. In my opinion, it's best to use third-party services for it and not to do some really big work, and not to do it by ourselves, because it saves our time. And the last question, which I wish you all to answer at some point, what if your API is successful? So you have a lot of customers, they want to use API, so you want to scale it. Yeah, it's not in the garage stage, it's a production, it's live. So how will scale it? Is it scalable at all? There are many more questions, but these are, I chose the most important questions for me at this point. And when you're done with them, when you have answers, you can go to the next stage, which is designing. What I mean by designing. When you know who will use your API, you want to learn the language. You want to learn the area they work with. That's called domain. You want to basically you want to start to a bit think like these people think. Document this knowledge. And also to, if you can study what others did in similar domain, it's a great experience. You can start with some non-zero level, and you can see how you can improve existing APIs and not to do from zero. When you know the domain, you should start identifying domain entities that are objects your API operate on. For example, for payments, it would be payment account, some I don't know, amounts, some bank, yeah, country, currency, and you should also provide some or define some important actions you can do on these entities. And then you identified entities, you should think and identify key flows. So these are flow that is multi-step activity. Yeah. So fetching data is single step activity, but making a payment is probably at least a 2-step activity. Yeah. On the first step, you can, for example, you can create a lease. Yeah, on the second step, you confirm this payment with your credentials or something like that. Let's suppose that you did this homework. You have your domain designed, written down, documented, and you understand what you will work with. So then you can go to the technology choice. And here the controversy begins, because at the moment, when it comes to web APIs, there are two basically mainstream approaches. The first one is REST, and the second one is GraphQL. There are also around maybe 10, maybe 20, or something like SOAP or XML RPC approach or JSON RPC, but they are either old, not very often used, or too complex to be used effectively. So hopefully you will not work with them. So I will not mention them. The biggest differentiating factor between REST and GraphQL is the REST is it's somewhat academic. It's about modeling data and transitions in state between of this data. It also tries, as much as it can, rely on the existing web infrastructure, that is HTTP protocol. GraphQL, on the other hand, is about flexibility and great developer experience. And probably these are two factors that contributed to GraphQL success. Other often cited advantages are arguable. I can argue with it on private or maybe in next presentation. But in my opinion, this flexibility and great developer experience, this 90% of what GraphQL does. Each approach has its good and bad parts. For REST, it's actually better. It's not an approach. It's an approach, and it's not a strict specification. Plus, of course, it can leverage existing web infrastructure. Bad thing is it lacks data definition language. But on the other hand, it allows defining custom schema definition language. And there are several competing functional specifications like OpenAPI, JSON API, or data that do that. But for me, the most important factor is the lack of proper tooling for REST APIs that make working with them tedious and error-prone. GraphQL, on the contrary, is a specification with the very well-defined schema definition language. There are some disadvantages of using this GraphQL, but what I want to know that its tooling and client-side developer experience are top-notch. It's very good. It starts to be difficult to work with on the complex scenarios when you have multiple services, each with its own schema. You want to somehow optimize the fetching data from multiple services. You want to somehow to merge this data schema of the services. So then things with GraphQL start to complicate. But if you don't require this, it's okay. This is what I created for myself as a somehow checklist for whether to use GraphQL or REST. Basically, if you have clients with a strong those data requirements strongly vary, so you should consider using GraphQL. If you have a single greenfield service, that is new service, and you want to try GraphQL, you may use it. If the delivery velocity is really important and you know GraphQL, you can also use it. Otherwise, consider using REST. If your API, if you choose to use REST, but your API is complex, then add the schema definition to your API. And that's how we do things in Fresha. We use JSON API. Yeah, JSON API is a specification of how requests and responses to the REST endpoint should look like. And in principle, it does the same as GraphQL schema. But it does not require us to use always GraphQL stack. So when you're done with the technology choices, you should really think about great developer experience. And also a subjective list, bit opinionated, is you should think about naming. It's very important, consistent naming. You should use commonly used patterns. You should try not to reinvent the wheel and invent the new ways of doing the same things, because it's simply faster, and the developers already get used to these commonly used patterns, so you will save them time. You should really think and invest into documentation with code snippets. If you have time and resources, you should write SDK for popular languages like this. For web, that is JavaScript, or better TypeScript. Your API should provide debug mode. That is a mode in which all errors have very, very detailed messages. So the developer which which sees this error does not have to do much. Either he or she has an explanation what went wrong, or she or he has a link where he can find this information. And the very desired quality, which helps with the developer experience, is providing sandbox environments. That is a fake environment where you can test your API, how it looks, how it feels, which errors, how it responds to given APIs, to given requests. And now let's see these steps in more or less detail. Here is the example of GraphQL query. Usual questions I have seen this query is, what is the difference between gadget and UI device? Is it different or is it the same? Same with the name and title, because they may be the same, or they may mean different things. And also, I will always have a question: why is snake case used in one case, and is it a common naming pattern, or is it an error? Here are two examples how to do. For example, how to form a URL for a paginated resource in REST style, how to do it more or less properly, and how not to do it. Yeah, the first one, probably you saw URLs like this 20 times, maybe 50, yeah, and you will not have problems with changing the parameters accordingly. But when it comes to the second one, you really need to think what these parameters mean. Does it 20? It's a constant, or is it parameter, or whatever. Documentation. It's very important, yeah, because not everything can be written and expressed in code. The things cannot be expressed, should be documented. Here I listed three APIs actually, and one tool, the Swagger editor, which I like very much. I think they have good quality, and if you will go to them, this is SendGrid, Google, and GitHub APIs documentation. Yeah, if you go to them, you will see that they have common qualities like response request definitions. They allow you to send some sample request and see the output. Yeah? So it's live. But documentation is good, but the code is better. So if you can just write the SDK, because you are the person who creates this API, you know it's best. You just can provide, do a big favor to developers and provide them with it and save them some time. Yeah. Same goes with the debug mode. Yeah. Here I show an example of how error message can look like. So it should have a code, some definition, and maybe even stack trace. Of course, when you choose REST, you should also obey to HTTP rules and use error codes wisely. Yeah, you cannot do this in GraphQL, but you should do this in REST APIs. And the last topic is embrace future changes. Changes are inevitable, so you should plan how you will version your APIs and how you evolve them, change them right from the beginning. REST and GraphQL have different approaches to this matter. REST advocates that URLs should be versioned. There are three different schemas for that. whereas the GraphQL recommends versionless evolution. So they have one single schema, no versions. Just when you need some new field, you add them. When you want to remove something and you know that your client do not use this field, you just remove. Personally, I do not like GraphQL approach because I think that these changes should be explicit. Hiding some new stuff, new fields, remove old fields can be unexpected for your future clients. Besides that, not every change requires new version. What do I mean by that? It's when you many changes, for example, adding new fields or changing the semantic, do not require issuing or creating a new set of endpoints for that versions. So these new versions for new endpoints and new versions for REST APIs are really not that will not happen not that often. So this was the one of arguments against REST versioning model. Okay, so we can got to the end. Just to summarize, the main point of my presentation is API is a product, so treat it like one. Start with the collecting requirements, then do some design, do some homework, learn the domain, then choose the technology, but wisely. Then really think about developer experience, because developers will be your most of your clients will be other developers. And then think about developing and evolving your APIs. So that's all. Thank you.
Congratulations. If we were live, there will be great ovations and, and we will all clap our hands. There is a question from Gondron. Do you work from the domain outwards entities in variants first, or from the API shape first inward? What's first, nouns or verbs?
Nouns. In my project, nouns are first.
Okay. So this means you plan the entities first and the commands and methods later. Okay. Why so?
But it's not black and white. Sometimes name of the entity is the name of the activity. For example, payment. Right? Payment can be a noun, and payment can be an activity. Pay or pay, right? So sometimes, or frankly, there are no good examples of that right now in our mind. But sometimes you will have REST endpoints which will serve which will do some strict activity which cannot fit in the entity state. But these are rare cases.
Okay, so I think it answers the question. Now Marcin Hagmeier has a question. Marcin asks, what do you think about sending executable scripts to the server to perform the required computation, as it is in AskQL?
Actually, this is not only a feature of AskQL. REST approach also advocates it. It's one of the constraints. But frankly, I never tried it. I never tried it because of security concerns.
Okay, so you are afraid that maybe the front end will send some executable script which can be dangerous.
Exactly.
All right. Okay, So I can't see any other questions, so I will invite you to the networking session on Discord. I shared the link on Slack, so you obviously you're all invited, and you can ask more questions to Andriy in person. So thank you very much, Andriy. Awesome presentation, very informative, and we really need more presentations like this. So thank you very much for